Today what we're going to be talking about are welding symbols. So this is all going to play into how to read a blueprint when you're actually out there in industry and you're performing your duties as a welder. So we're going to cover some things like what do welding symbols mean, what do they consist of. We're going to go over several examples of how they might look like and then what that translates into as far as the deposited weld. So moving on to the next part, there are 5 common welding joints. They are T-joint, lap joint, butt joint, corner joint, and edge joint. Everything you do out in industry is going to boil down to some variation of one of these 5 different welding joints. But the welding symbol is going to give us some extra information like how to prepare the material, if there's any preparation or extra preparation that is involved. It's going to let us know how we need to weld each joint. So it's going to describe things like the size of the weld, how deep we have to penetrate into the material, if there's a specified amount of penetration we need to have. We'll see things like maybe the type of welding electrode we need to use, the type of welding process, and then also other things like, are we going to just chip the weld? Are we going to hammer it? Are we going to grind it? Are we going to machine it? There are a lot of different things that go into a welding symbol, but at its basic foundation, we always start with one of the 5 welding joints. Now, real quick, before we get any further, I do want to get into a little bit of a terminology thing. So you're going to hear me say weld symbol, and you're going to hear me say welding symbol. So there is a difference between the two. The weld symbol is going to be the symbol or the icon that describes the basic weld itself. And then the welding symbol is going to be the weld symbol along with all the other bits of information that are going to go into how we prepare the material, how we weld the material, and then any kind of after weld procedures that need to happen. So one more time, the weld symbol is going to be the shape or the icon that tells us what type of weld we're making, whether that be a groove weld, a fillet weld, a spot weld, anything like that. And then the welding symbol is going to be the weld symbol plus everything else. Here's a snapshot of the reference line from the AWS and all the bits of information that you could find as part of the welding symbol. Now there's a lot to go over here, but we're not going to cover everything in this video. We're going to keep it simple and just the things that you need to know right now that pertain to a fillet weld. But feel welcome to pause here, glance over, take a picture for yourself. That way you have something to reference later on. Okay, so if we looked at the last example, we can tell that there are a lot of elements to the welding symbol. At first it can be a little intimidating, so let's start basically at step 1. Let's start with the foundation or the basis of the welding symbol. And so everything that goes into a welding symbol is going to be written on what's called the reference line. Now, the reference line at its most basic form is just a straight horizontal line. Now, usually at one end or the other, it's going to break, meaning it's going to change directions. It's either going to point up or it's going to point down. So let's just start this reference line pointing down. Now at the end of this line, there's going to be a filled in arrow point. So this right here is what makes the reference line. Again, a straight horizontal line followed by a break, which leads into a second line, with a filled in arrow point at the end. Now, there's also a third part to the reference line. This is what's called the tail section. Now, the tail section will always appear opposite of the arrow point. One thing I'll make note of here is that the tail section is actually optional. There are a lot of bits of information that can be turned into a symbol or abbreviated into simple numbers, and that'll be written on the reference line itself. Anything extra that the welder needs to know, like specifically what welding process to use, if the welder needs to look at another page to reference notes that will relate to the weld being made, or if, just anything that cannot be abbreviated or drawn as a symbol is going to be typed in into the tail section. So sometimes you'll see a tail, sometimes you won't. If there are no additional notes that the welder needs to be aware of, then the blueprint, when the blueprint is being created, the tail section will actually be omitted. So you may not see this. You may only see this part of the reference line versus the tail being included. Just something to keep in mind. Now, when we get our blueprints and we start seeing reference lines all over the print, making up a whole bunch of different welding symbols, you're going to notice a couple different things. You're going to see weld symbols either on top of the reference line, or you're going to see them on the bottom of the reference line. Now, this does tell us something different about the weld that's to be made, because depending on what side the information is included, that's going to tell us something unique. So when we look at what's on the bottom, instead of saying the bottom of the reference line, this is actually called arrow side. All right, so one more time, everything that's written underneath or on the bottom side of the reference line is called arrow side. Now, everything that's drawn on top of the reference line is called other side. And so other side and arrow side are a breakdown of what's called side significance. So remember how I said earlier, depending on which side the information is drawn on, that's going to tell us something unique about the weld that's to be made. So when we're talking about side significance, here is where I want to introduce the first weld symbol that we're going to be discussing. It's going to help us to better understand how arrow side and other side work. So the first symbol I'm going to give us is going to appear as a right triangle. Now, if you have your hand out, go ahead and take a moment, pause here, try and see if you can identify what this symbol is. So this symbol is the fillet weld symbol. So like I said, it is essentially a right triangle. Now, the symbol for a fillet weld is always going to have that vertical straight leg on the left-hand side. So you're always going to see this leg right here on the left-hand side. Same thing if it were to be drawn on the other side. You'll always see it on the left-hand side. Just like that. All right, but let's only focus on one for right now. Okay, so to help us understand side significance using a fillet weld on the arrow side, I've drawn up just a quick illustration of a T-joint. And this is, you might not see something like this out in the industry, but this is more or less how the projects on the blueprint are going to be drawn in relation with the welding symbols. So the welding symbols are always going to point somewhere along the project that's to be welded. This is how we know the weld that's being placed in that or around that location is going to be done however the information on the reference line specifies. So with a fillet weld on the arrow side, how do we know where to deposit this weld? So this is actually pretty easy. So when everything is on the arrow side, it's as simple as just following the reference line to wherever it's pointing, and wherever it's pointing to on this particular joint is where the weld is going to go. So if we use this example, we follow the reference line all the way down, it's pointing to this side of the T-joint. So this is where the fillet weld is going to be deposited. Right in there. Okay, so I'm gonna leave this up here so we have something to compare it to. But what if we have a fillet weld symbol on the other side? So on the top of the reference line, how does that work? So we're gonna follow the same principle as if we were looking at a weld symbol on the arrow side. We're gonna follow it down, see which side of the joint is being pointed to, but because it's written on other side, we're going to skip over to the opposite side of the joint that the reference line is pointing to. So the reference line is pointing us to this side of the joint, but because the weld symbol is on the other side, we're going to hop over and deposit the fillet weld over here. That's pretty much what side significance is. We have arrow side, other side. Arrow side, you will deposit the weld on the side of the joint that the reference line points to. Other side, you find where the reference line is pointing to, and then you skip to the opposite side of that joint. Okay, so here is another example. We have the reference line now flipped, going in the other direction. What happens if we come across a welding symbol and the fillet weld is on the bottom? Does this change side significance? So actually it does not. So whether the reference line is pointing to the left, whether it's pointing to the right, up or down, or if there are multiple breaks in the reference line, whatever is written on the bottom or arrow side is always going to be arrow side. Everything that's written up top is always going to be other side. So same principle, we're gonna follow the reference line, see which side of the T-joint is being pointed to, and that's exactly where we're gonna deposit our fillet weld. Now the same goes, of course, again, for anything that's written on the top side, or in this case, other side. We're gonna find which side of the joint is being pointed to, and then we're gonna skip over to the opposite side, and that's where we're going to deposit our fillet weld. All right, before we start moving on to what additional bits of information we can find in a welding symbol that relates to a fillet weld, I think it's important to understand the various elements of a fillet weld. So that way, whatever you're reading on a reference line, you'll be able to identify exactly how the fillet weld needs to be deposited. And so we're going over a fillet weld first because when you're starting out as an entry-level welder or you're starting out as a welding student, this is the type of work that you're mainly going to be doing. Now, as you work your way up and you start getting into intermediate classes, you'll start going over groove welds because they are much more difficult, and that's more than likely what you'll actually be doing in industry. So before we start talking about groove welds, we first need to understand all the various concepts that go into a fillet weld. So I've just got a big old T-joint drawn up here with a big fillet weld, and we're going to start looking at the different elements of a fillet weld. The first part of the fillet weld that I want to go over is called the root. Now, I'm pretty sure this is a term that you've heard pretty often. When we start looking at the T-joint, the root is going to be the deepest part of the joint. So this is going to essentially be the deepest point of the weld. So with a T-joint and a fillet joint, the root of your fillet weld is going to be right here. So where the two plates meet, and essentially the deepest part of the fillet weld. You can think of this also being as the point on the welding joint that your electrode is going to make contact with when you start your weld, depending on the welding process. So again, the root is the deepest part of the fillet weld where it makes contact with the welding joint. All right, the next element or the next part of the fillet weld that I want to talk about are the toes of the fillet weld. Every weld is going to have two toes. You can think of them as the edge of the weld or the area of the weld that transitions into the base metal. So with this particular illustration, the toes of this fillet weld are going to be here and right there. So the two corners or the two edges of the weld where they meet the base metal, not to include the root. So you're going to have one toe here, and you're going to have the other toe right there. Now the next part of the fillet weld that I want to talk about are the legs. So same thing with toes, the fillet weld is going to have two legs. Now the leg of a fillet weld is the length or the distance that the weld extends from the root to either side of the weld. So the leg, again, in another way to describe it, is the distance between the root of the weld to the toe. So you'll have one leg starting at the root right here, extending all the way to this toe. That's considered one leg. The second leg will start again at the root and extend upward until it gets to this toe. So we have one leg here, one leg there, and it's the length of the weld from the root of the joint or the root of the weld out to the two toes. Okay, I've got a second fillet weld drawn up here because there's a couple more elements and I don't want to jam pack too much stuff on the one fillet weld. So the next thing I want to talk about is the face. Now the face is what we see when we're looking directly at the front of the weld. So if we're over here depositing the weld down and we're looking in this angle towards the weld, this right here is the face. So whatever we see on top of the weld, this right here is going to be the face. So you can also call this the surface of the weld. Now there's one more element, and this is called the throat. The throat is pretty similar to the legs. It is going to be the distance from the weld root to the face. So the root of the weld is down here. The throat is going to be the distance from the root to the face. Now, it's not necessarily the distance from the root to the face down here or over here. It's basically going to be the distance to the center of the face, which theoretically should be the highest point on the surface. Now, when we start looking at additional information on a welding symbol, for example, weld size or the size of the weld, this is where we need to know legs, toes, throat, and face. Because a lot of this is going to come together to help us judge whether or not we're making an appropriately sized weld, if it's too big or if it's too small. Okay, so back to the reference line. Now that we understand some of the elements of a fillet weld, we can start talking about the size of the fillet weld, which is more than likely the next piece of information that you'll see written on the reference line. So here I've got a reference line with a fillet weld symbol on the arrow side, and again I've got a little mock T-joint. So what happens if you see a welding symbol that appears like so, and then you get a number on the left hand side of the fillet weld symbol? Let's say 1/2. So anything that's written to the immediate left of the fillet weld symbol is going to tell us the size. The size of the fillet weld will always be written on the left hand side. Now if you see a fraction like 1/2, this is telling us 1/2 of an inch. If you see a decimal like 0.5, this is still telling us 1/2 of an inch. The only time the unit of measure changes is if it's actually specified. So if you see something like 2 and then the abbreviation for millimeters or the symbol for millimeters, then that's when the unit of measure changes. Otherwise, if there's no unit of measure specified, always assume that the measurement is in feet and inches or fractions of an inch. So let's go back to 1/2. So 1/2 is going to be the size of our fillet weld. So that means when we're depositing our weld, the legs need to extend out from the root 1/2 of an inch. Now, this isn't a perfectly drawn fillet weld, so my apologies, but if this were correctly done, starting at the root of the weld or the root of the joint, this leg should extend out 1/2 of an inch, and this leg starting at the root going to the toe should also equal 1/2 of an inch. This is how we determine fillet weld size. Now let's throw in here another example. Let's say we've got a fillet weld on the other side, but instead of 1/2 of an inch, we see something like, let's say 3/4. So there's nothing that follows 3/4. We don't see any symbol for millimeters or centimeters. So we're going to take this as 3/4 of an inch. That means the weld that's being done on other side. Oh, forgive me. My T-joint wasn't big enough to hold that fillet weld, but we're going to assume that it's appropriately sized. That means that from the root of the joint, or the root of the weld, this leg is going to extend out to the toe, and it's going to equal 3/4 of an inch. Same thing with this leg going up the plate. It is going to equal 3/4 of an inch. So I did my best to kind of show you that if you have one weld specified at 1/2 of an inch, it's going to be a little bit smaller than the weld that's being called out to 3/4 of an inch. One more quick example. If we have a welding symbol, fillet weld, and the size being specified is 0.125, or in fractions that equals out to 1/8 of an inch, when we deposit our fillet weld, this leg, starting at the root, extending out to the toe, is going to equal 1/8 of an inch. And then this leg running vertically, also starting from the root, going up until the toe, is going to equal 1/8 of an inch. So whatever the size is being specified, think of it as that is the length of the legs for your fillet weld. Okay, so we've established that the size of the weld is always going to be drawn on the left side of the symbol. Now, when we're talking about, if we're welding big assemblies, do our welds need to be the entire length of the joint? Or are we only welding, shorter increments? So if this is something we need to know, how or where do we find it on the welding symbol? So the length of the weld, at least with fillet welds, is always going to be drawn on the right hand side. So length is always going to appear right here. Now, if there's nothing specified immediately to the right of the fillet weld, then we can just assume that if we're welding this T-joint, and so just kind of imagine we're looking at a T-joint from the front view instead of the side, our fillet weld is going to essentially start over here, and it's going to extend the full length of this T-joint. But if we were to see a number directly to the right of the fillet weld symbol, let's say for example we see the number 6. Then that pretty much means if we're welding whatever it happens to be, in this case we have a T-joint, the start of our weld all the way to the end of our weld is going to measure 6 inches. Just the same if we were to, instead of a 6, see something like, I don't know, let's say a 3, then the start of our weld measuring out to the end of our weld is going to be 3 inches. So whatever number you see directly to the right of your fillet weld is going to tell you how long your weld needs to be. Okay, now that we've got size and length out of the way, if we are welding fillet welds to a certain length, and let's say they have to be spaced apart, how do we know how far they need to be spaced apart? So this is kind of going under fillet weld spacing. You can think of these types of welds as stitch welds, but the more appropriate term is intermittent welds. So when you have sections of small welds kind of following in line with each other. So we've got size to the left of the fillet weld symbol, length to the right of the fillet weld symbol. The spacing is what's called pitch. So pitch is going to accompany length being drawn on the right hand side of the fillet weld, but you're always going to see length and pitch together. You're going to see a number for length, so let's say 1, and you're going to see a number for pitch, let's say 2, and they're always going to be separated or essentially combined using a hyphen. So if you see something that looks like this, the first number is going to be your length, the second number is going to be your pitch, or essentially the spacing between the two welds. So for this example, let's say we've got a welding symbol and we have a length of 1, a pitch of 2. That means the length of our weld is going to be 1 inch. So if we get to welding our T-joint, the first weld is going to be 1 inch in length. So now, how do we determine the spacing we need to have in between them before we start depositing our second or our next weld. So it's different than what you might think at first. Some people will probably take this number 2 and say, okay, if our weld is 1 inch long, then that means starting at the end of our weld, we're gonna skip forward 2 inches and start the next weld. But that's actually incorrect. The way that we do this is we're gonna find the center of our first weld. So if this is 1 inch long, we're gonna kind of draw a line, or we can look at it with an imaginary line. If we're out on the job site, we don't have anything to write with. We're going to find the halfway point, or in this case, half of 1 is a half. So half an inch in. And we're going to then skip forward the 2 inches. So come this way 2 inches, and then we're going to draw a straight line down. That is going to be the center of our next weld. So when we think of pitch, pitch is the distance from the 2 welds, from the center of the first or the previous weld to the center of the next weld. So real quick, one more time. If our first weld is 1 inch in length, we're gonna find the middle, which is at half an inch. From there, we're gonna draw a line, and then we're gonna skip forward 2 inches, draw a line straight down. That's gonna be the middle of our next weld. So if we know half of the weld needs to be on this side and half of the weld needs to be on that side, with the length of our weld only being 1 inch, this means that half an inch is gonna go over here, and the other half of an inch is gonna be on that side. And we'll continue to follow this pattern until we reach the end of our joint. All right, our next example of length and pitch, let's say we have 2 and 5, so a length of 2 and a pitch of 5. So this means our first weld is going to start out on one side of the joint, and it's going to extend out 2 inches. Now, we're going to find the middle of this weld. So the middle of this weld, or half of 2, is going to be at the 1 inch mark. So we're going to measure 1 inch in. And from there, we're going to measure out 5 inches. So measure out 5 inches, draw a line straight down. This is going to be the center of your next weld. Now here we have to do a tiny bit of math. If we look back at the welding symbol, we're going to see that the length of the weld is 2 inches, right? So half of the weld is going to go on one side of that line that we just drew, and then the other half of the weld is going to go on the opposite side. Well, half of 2 inches is 1 inch, so 1 inch of weld on either side. Now the next thing I want to talk about is changing the appearance of the face of the weld, changing its shape, something that's called weld contour. Now there are 3 different types of contours and 3 types of contour symbols. They are flat, convex, and concave. Now whichever symbol you get, they're always going to be placed at the same spot in relation to the weld symbol. So with the fillet weld symbol, they're going to be placed right on top. So starting with the first one, the flat contour, this is drawn as just a straight line. And if we ever need to make our welds appear flat, then this symbol is going to go right above the fillet weld symbol, like so. So when we get to depositing our fillet weld on this T-joint, instead of the face of the weld rounding out away from the weld, it's actually going to just go straight across from one toe to the other. Now, depending on the welding process that you're using in your technique, you could achieve a flat looking weld right off the bat. However, if there are any after procedures you need to follow, anything special that you need to do in order to achieve a flat looking weld, there are some other bits of information that you'll see accompanying the contour symbol. You'll see a letter, which is an abbreviation for the process you need to use. Just for example, if you see the letter G on top of a contour symbol, this means that you need to grind the weld in order to achieve that contour. If you happen to see the letter H, this stands for hammering, so you need to hammer the weld in order to achieve this contour. If you see the letter C, this stands for chipping, so you need to chip the weld in order to achieve this contour. And if you see the letter M, that stands for machining, so when you're done welding, you need to machine the weld in order to achieve this weld contour. And you can see any of these letter abbreviations used with any of the contour symbols, whether again that's flat, convex, or concave. Now the next contour symbol we'll be talking about is the convex contour symbol, or some people call this convexity. This is just a simple outward curved line. Some people will say it resembles a half circle or a crescent moon, sort of. And when we're depositing a fillet weld that's supposed to have some convexity to it, it's going to have this outward curve on the face. So it's going to look like we've got some reinforcement in there. Again, there's a build-up outward curve, and a lot of times we can achieve this just by using regular welding technique. And the last contour welding symbol we're going to be talking about is the concave weld symbol, or concavity. Now it's going to be just the opposite of convex, where convex is an outward curve, concavity is an inward curve. So as we look at the side of a weld that needs to be concave or is concave, it's going to appear like the surface is bending inward towards the root of the joint. Alright, so it's going to look like it might be underfilled, like we didn't put enough reinforcement in there. Now, some of you out there who are familiar with welding already and have some experience in the field, you're probably thinking to yourself, when is it ever going to be ideal to have a concave weld? Isn't that kind of defeating the purpose of structural integrity? So depending on what type of work you're doing, and if there's going to be a part that's going to be welded right next to whatever you just welded, you might be kind of tight on room or space for this next part to be welded onto. And so you might have to remove a little bit of that weld material depending on what your tolerances are. So there may be times where you have to remove some weld metal in order to make room for something else. Alright, so one more time, the three contour weld symbols that you can come across are flat, convex, and concave. The flat contour symbol is just a straight flat line. The convex contour symbol is an outward curve, so curving away from the root of the joint. And then the concave weld symbol is an inward curve, or thinking of it as curving in towards the root. And if there are any specific procedures you have to follow or methods to use, those will also be specified by the first letter of the process. So G being grinding, C being chipping, M being machining, H being hammering, and there's actually one other letter that I forgot to mention. It's the letter U. Now the letter U stands for unspecified, which basically means do whatever you need to do in order to achieve this contour. Hey everyone, welcome back. In this video we're going to be talking a little bit more about weld symbols, welding symbols, but we're going to move away from fillet welds and we're going to start talking more about groove welds. So there are a lot of groove weld symbols out there that you might see, but in this video we're only really going to focus on two, the bevel and the V groove. So we're only going to focus on these two weld symbols for this video, just to kind of keep things short. Groove welds can be pretty extensive with all the information that you might see on the reference line as part of the welding symbol as a whole. So like I said, to keep this video a little short, we're only going to go over the bevel and the V groove. Now when it comes to bevel and V grooves, you'll see those symbols written on the reference line one of two ways. So for the single bevel, if the single bevel is to occur on the other side, you'll see it written just like this, where it's on top of the reference line. Now, if the bevel is to occur on the arrow side, you'll see the weld symbol appear below the reference line like this. And just the same with the V groove weld symbol. If it's to be on the other side, you'll see it placed on top of the reference line. And if it's to be on the arrow side, you'll see it below the reference line. Now, when you come across a single bevel weld symbol, the question comes up of which plate receives that edge preparation, or which plate is going to receive the bevel and which plate is not going to receive the bevel. So it's kind of as easy as just following the reference line, seeing where the arrow is pointing to, but there are some things that we need to look out for. So in terms of answering this question, this is how we do it. If we were to have a simple butt joint like so, and we have a welding symbol that gives us a single bevel weld symbol, and we're trying to figure out which plate we need to bevel and which plate does not get beveled, in this easy example, all we do is we follow the reference line and we look at which plate it's pointing to. So in this case, the reference line is pointing to the plate on the left, which means that on the arrow side of this joint, we would be placing the bevel. And that means the bevel would go right here. But now we have the same butt joint, we have pretty much the same welding symbol, and now the single bevel weld symbol is appearing on the other side. So the way that we figure out where the bevel goes is we follow the same first part of that last principle. You follow where the reference line is pointing to. In this case, it's pointing to the plate on the left, but now the weld symbol is on the other side, so we need to flip where the bevel is going to occur. So instead of it occurring like this, it's actually going to occur like that. And the bevel would go in like so. All right, now we've changed things up a little bit. We have the same butt joint, the same weld symbol, but now there's a break in the reference line. So instead of pointing to the left plate, the welding symbol is now pointing to the plate on the right. So we do pretty much the exact same thing here. We're going to follow the reference line and see which plate it's pointing to. It's pointing to the plate on the right, and the weld symbol is on the arrow side, which means that the bevel is going to take place exactly where the arrow is pointing to. So the bevel would be put in like so. Now we have the exact same setup, but the bevel is now to occur on the other side. Follow the same principle, see which plate it's pointing to, and now instead of the bevel being placed on top of the plate, it would be placed on the bottom because the bevel weld symbol is on the other side of the reference line. It would go in like so. Here's a welding symbol that tends to throw a lot of students off. So on the welding symbol, we see that there are two bevel weld symbols. So two single bevel weld symbols. And we have the same butt joint. Now, a lot of students will take this as, okay, I need to bevel this plate and I need to bevel that plate. So in essence, both plates would look like this. But that's actually incorrect. So by preparing your material like this, instead of creating a double bevel groove weld, you've actually just created a single V groove. So how do we prepare a double bevel groove weld? We're going to follow the same principle as before. We're going to follow the reference line see that it's pointing to the left plate, and remember, these symbols are referring to a single bevel, which means only one of the plates is going to be receiving this edge preparation. So with the reference line pointing to the plate on the left is going to receive a bevel on one side and a bevel on the other. So it's going to look something like this. Just like that. Now, just the same if we were to have a break in the reference line, if the reference line now points to the plate on the right, if we have two single bevel groove weld symbols, this plate on the right is going to receive a bevel on the top and a bevel on the bottom. Just like that. One last thing, whenever you're in doubt on how to read the weld symbol and how to prepare your plates, always look back at the weld symbol. The weld symbol is going to show you the shape of the groove. So in this perfect example, the two single bevel weld symbols are showing you essentially one plate that receives a bevel on the top and a bevel on the bottom, and then the plate next to it is going to have that square edge. So think of it as looking more like this. We have the plate with the square edge over here, and we have the plate with the double bevel over here. Now let's move on to a V-groove weld just for a moment. So if we have a single V-groove weld symbol on the arrow side of the reference line, and we again have our butt joint example, figuring out how these plates are going to be prepared is pretty much done like this. As all the other examples have gone, we're going to follow the reference line, see which side of the joint is being pointed to. That way we can determine, okay, this is how other side is going to affect this and arrow side. And it's pointing to the top of the joint. Now the weld symbol is on the arrow side of the reference line. So that means pretty much where the reference line points to is where that groove weld is going to be put in. So both of our plates are going to receive a bevel, which is going to create a V groove. Just like that. Now, if we come across this almost the same example, but with the V groove weld symbol on the other side, we're going to follow the same procedure. We're going to follow the reference line down, see which side of the joint the reference line is pointing to. So in this case, it's still pointing to the top. Now, with the weld symbol being on the other side, we know to place the V groove at the bottom sides of both plates. So each plate is going to be beveled like so, which again is going to create a V groove. Now what happens in the event if we have our same butt joint, we have the same weld symbol, but now there's a break in the reference line? How does this affect how we prepare our material? So in the case of a single V groove, a break in the reference line actually doesn't affect anything. So because both plates are receiving a bevel with a single V groove, there can be a break in the reference line and it's not going to affect how the plates are prepared. It was probably drawn this way because it was just the easiest way for the engineer to put this information on a blueprint. So just remember, if there's a break in the reference line with a V groove weld symbol, there is no change in how you prepare the plates. It doesn't matter if the reference line points to this plate or points to that plate. Both plates are going to receive a bevel, which together create a V-groove. So with the reference line still pointing to the top side of the joint, and with the V-groove weld symbol on the arrow side, both plates are going to be beveled like so. And just the opposite, if you were to see the weld symbol appear up top, instead of beveling both plates on top of the joint, you would bevel them in the opposite manner. So on the bottom side. Just like that. Now in this example, we still have our butt joint, and now we see that there are two V-groove weld symbols, one on the arrow side, one on the other side. So we're going to follow the same principle. We're going to see which side of the joint the reference line is pointing to, and because both sides of the joint are going to receive a V-groove, all that's telling us is that these plates are going to be beveled on both sides. So there's going to be a V-groove on top, and there's going to be a V-groove on bottom. So both plates are going to end up being prepared like this, so that way there's a V-groove on top, V-groove on bottom. Now, a lot of people are under the assumption that you only see groove welds when you're using butt joints, but that's actually not the case. You can see groove welds used with a number of the 5 common weld joints. So this is just one example where you can see a groove weld being used with a T-joint, where a lot of people are used to just your average everyday fillet welds. So in times where you need complete joint penetration on a T-joint, you could bevel one of these plates. And so you'll follow the same principle as before. You're going to see which plate the reference line is pointing to, and then again, which side of the reference line the groove weld symbol is being placed on. So in this example, the reference line is pointing to the top plate, and it's pointing to this side of the joint, and the single bevel weld symbol is being given on the arrow side, which means that the bevel is going to be placed in like so. Just like that. Now, just the opposite, if the single bevel weld symbol appeared on the other side of the reference line, you're still going to see which of these two plates the reference line is pointing to, and we see here that it's still pointing to the top plate. And because it's pointing to this side of the joint, we are going to give this single bevel to the opposite side of this vertical plate. Just like that. Now when it comes to T-joints and any type of groove weld, you should always think, or always kind of look back and remember that more times than not, this vertical plate is going to be the one to receive the groove or the bevel or any other type of preparation. It makes almost no sense to deliver any kind of edge preparation to the bottom plate. So let's say you come across the same welding symbol, and if you were to bevel the bottom plate instead, that really doesn't benefit the joint whatsoever, If the weld is going to occur either right here or right in here, beveling the bottom plate either on this edge or over here, say something like this, it's not going to benefit the weldment whatsoever. So this is where common sense kind of comes into play. If you were to think about beveling the bottom plate, it's not going to get you anywhere. That bevel preparation or that groove preparation has to be applied to that top plate. You need to see where the joint is, or where in the joint the weld is going to be deposited, and use that information to help you determine which plate is going to receive that groove preparation. Okay, so now that we've talked about how to determine where the groove preparation is going to take place, is it one plate or the other, or both plates, and then top or bottom, the next thing we need to understand is how to determine how deep that bevel goes. And actually, before I move on, let me fix my little mistake here and complete this reference line. Okay, so when you have a welding symbol that's giving you some type of groove weld, we need to know how far down or how much of this material we're going to bevel. So are we going to bevel just a little bit? Are we going to bevel a lot? You know, how do we determine the depth that the bevel is going to go? So this is where the first piece of information comes aside from the weld symbol. So if you see a number to the left of the groove weld symbol, doesn't matter if the symbol is on the bottom, which is arrow side, or if it takes place on the other side, the depth of bevel is always going to be located to the left of the weld symbol. So in this case, the welding symbol is telling us that the depth of this single bevel groove weld is going to be 1/2 of an inch. So let's go ahead and say that the material you're given is 1 inch in thickness. So that means that your bevel is going to extend from the top side of this left plate right about to the middle. So you'll find your middle point, and then you're going to bevel from the top going down just like that. So you're only removing about half the thickness of this plate. So just like that. Now with your bevel only being 1/2 an inch, that means that your root face is going to be 1/2 an inch. So I get this question a lot from students. If they have to put a certain size bevel on their plate, what size should their root face be? Or a lot of people will refer to this as your landing. So this is where I say that there is some math involved. If you know the thickness of your plate and you're given a certain depth of bevel measurement, then whatever is left over is obviously going to be your root face. So going back to this example, if your plates are 1 inch in thickness and your bevel extends down 1/2 of an inch, that means you have 1/2 of an inch left over, which is going to be your root face. Now I left this previous bevel up here because I want to show you the differences in depth of bevel. So we still have 1 inch thick plates. This plate, remembered, was beveled with a 1/2 inch depth of bevel. Now this plate, or excuse me, starting with the reference line, this single bevel is going to be applied with a 3/4 inch depth of bevel, which means that on this plate on the right, we're going to find 3/4 of an inch down. Remember, this is about halfway. So now we're going to go down a little bit further, and that's where our bevel is going to end. So now we're just going to bevel our plate, hit that 3/4 inch mark. And that's how our plate is going to be prepared. So you can see that a 3/4 inch depth of bevel is more than the 1/2 inch depth of bevel. So now with this plate being 1 inch thick, if we've removed 3/4 inch material to make room for this bevel, that means we have 1/4 inch left for our root face or our landing. Now for our next example, still going with the butt joint, we have a single V-groove weld symbol, and it's on the other side. And we see a number written to the left of the weld symbol. This is going to be the depth of bevel. Now, we also have a different measurement. So our plates are only 1/2 inch thick. So we're going to follow the reference line down, see which side of the joint it's pointing to. It's pointing to the top, and with the weld symbol being on the other side, our bevel is going to occur right here. So with our depth of bevel being 1/4 inch, and both of our plates being 1/2 inch thick, we're essentially just going to find the midpoint, and we're going to bevel our material like so. Just like that. So we've got 1/4 inch down on both plates for this bevel, which gives us 1/4 inch left here and here. So your root face or your landing for both plates is going to be 1/4 inch. And for our last example for depth of bevel, let's go back to the T-joint. So we're given a measurement telling us that our plates, or at least this plate, is 1 inch thick. And our depth of bevel given next to this single bevel weld symbol is 7/8. So we're going to bevel into this material about 7/8 inch. So we're going to find wherever 7/8 inch is, and the easiest way to do that, if you're still learning fractions, or if you're still learning how to read a tape measure, is just find the middle, because that's going to give you 1/2 inch on both sides. Find the middle of that, which is 1/4 inch, and then find half of that. So right about there is going to be your 7/8, and then all you do is just bevel the plate out. Let's get rid of these other tick marks. And this is going to be how we prepare our plate. So there's a tiny bit left over. So if we've removed 7/8 for this bevel out of 1 inch thick plate, that's going to give us 1/8 inch remaining. So your root face or your landing is going to be 1/8 inch. Okay, so the next bit of information that we're going to talk about with groove welds is the groove angle. So we talked about how deep the bevel needs to go. Now we're going to find out how to determine the angle at which we are going to cut this bevel into the plate. So we're going to start with a single bevel first. And so we're determining first which plate is going to receive the bevel. The reference line is pointing to the left plate, so this plate is going to receive the bevel. The bevel is on arrow side, and we're seeing the 45-degree information being given to us. So the groove angle is always going to be provided just under the groove weld symbol if it's on arrow side, and then just above the weld symbol if it's on other side. Just like that. But we're only going to focus on one example. at a time. So let's just stick with the single bevel on the arrow side. So this plate is going to receive the bevel, and let's go ahead and say that our pieces are 1 inch thick. And to help us make more sense of this, I'm going to actually give us a depth of bevel. So let's say 1/2 of an inch. So now we know that at the 1/2 inch mark, this is where our bevel is going to end. Now, do we put a very steep bevel on it, or do we give it a very wide bevel? This is where the 45-degree information is going to come into play. So with the single bevel, it's pretty easy to determine how to set your groove angle. So if we were to make an invisible line going up with this straight edge, that's going to give us our starting point for the angle. Then we're just going to find 45 degrees. So we know if we were to follow this line straight up and then this top surface straight out, this gives us a 90-degree angle. 1/2 of 90 is 45. So we're going to make our bevel shaped just like that, but not in that location, because obviously we have to bevel into the material. So we're going to find the halfway point, because that's where our bevel is going to end. And then we go ahead and make our bevel at a 45-degree angle. And apparently I can't get a 45-degree line to save my life. There we go. So our plate is going to be beveled just like that. Now our next example is pretty much the same thing, but now there is no depth of bevel. If there is no depth of bevel indicated, then just assume that you are to bevel the full depth of this plate. So if our plates are 1 inch in thickness, then that means our bevel is going to end right here at this bottom corner. So still same concept, we're going to find a 45-degree line, and that is how we are going to bevel our plate. Just like that. So that way, if we were to draw a line straight up and then a line straight out from this bevel surface, this angle should be 45 degrees. And that's going to match the information that's given to us on the reference line. Now in this next example, we're going with a V groove. And here we can see that the groove angle is 60 degrees. So let's just continue on and say that these plates are 1 inch thick. Although in this case, it's not really going to mean anything, because I'm going to continue with this example without a depth of bevel. So in this case, we're going to bevel both plates all the way through to give it that V groove shape. And we need to make sure that our groove angle is 60 degrees. Now, here's where it gets a little tricky for a lot of students. Because both plates are being beveled, does this mean that each plate gets a 60-degree bevel, or how does it work? So some students assume, well, if with a single bevel, if we're given one, angle on the welding symbol, then that means that I would just assume that both plates get that. So if you follow that logic, each plate here would get a 60-degree bevel. However, that would be the bevel angle for each plate. Here, we're talking about the groove angle. All right, remember, going back to the groove angle. This means that both plates combined equal 60 degrees. So if from one bevel to the other is supposed to equal 60 degrees, then that means we have to split this evenly in half to where one plate gets 30 and the other plate gets 30. So that way when you add them together, they meet 60. So where a 45 degree would look more like the bevel extends out this way, we're actually going to come in a little bit shorter. So our angle is going to be more like this. So just like so. So that way with the entire groove angle, this is equal to 60 degrees. One plate receives 30, the other plate receives 30. So the angle measurement that you're giving is for the groove itself. That's why I said it's a lot easier to determine groove angle with a single bevel, because only one plate is being beveled. Here, both are being beveled. So we need to do a little bit of math, simple math. Whatever your groove angle is, if both plates are to be prepared, you're simply going to half this. So divide it by half. And whatever you get, that number is going to be the bevel angle for this plate and the bevel angle for that plate. So one bevel angle, second bevel angle, add together to create the groove angle. So that first example, we had 60 degrees. Here I'm giving us 90 for this example, just to show you the difference in the angle. So the first angle didn't really open up the V-groove a lot. 90 degrees is going to open it up even further. So again, no depth of bevel, so we're going to be beveling all the way through to the bottom of these plates. Now, from one bevel, so let's just go ahead and divide this into two. So 90 divided by 2 equals 45. So groove angle of 90 degrees means bevel angle of 45. So each plate is going to have a bevel angle of 45 degrees, which is going to look something like this. Now, if one plate has 45 and the other plate has 45, then that means from this side of the groove all the way to this side of the groove, this should equal 90 degrees, which is our groove angle, which then leads us back here, 90-degree groove angle. Now for this example, we've got a double bevel and two different groove angles. So first, determine which plate is receiving the double bevel. Follow the reference line down. It's pointing to the left side of the joint or the left plate, which means that we're going to have one bevel on top, one bevel on bottom. Now you can start with either one. Doesn't really matter. Now notice how there's no depth of bevel listed. So in this case, we can safely assume that both bevels are going to meet in the middle. So we can start with the arrow side. So this is going to be on top with a 45-degree groove angle. But remember, only one of these plates is receiving a bevel. So in this case, we can consider that to be the bevel angle itself. So groove angle is 45 degrees. So starting here, we're going to find a 45-degree line, and that's how the top bevel is going to be applied. Now the other side is going to have a 30-degree groove angle, so it's not going to be as open. 30-degree groove angle is probably going to look more like this. So you've got more material being beveled off the top, because that is arrow side with a 45-degree groove angle. and the bottom doesn't have as much being beveled off because the groove angle is smaller. All right, in this example, we have two V grooves. Arrow side, 60-degree groove angle. Other side is 90. So when we're beveling either plate or both plates to create a V groove on one side and a V groove on the other, we need to make sure that the arrow side is 60, other side is 90. So let me go ahead and just erase this for the moment to make some room. Let's start with arrow side. Now, there's no depth of bevel given on either side, so we can safely assume that both bevels are going to meet at the center or the middle thickness point of both plates. So 60 degrees, your top V groove is going to look something like this. Whereas your bottom one is going to look something more like this. So the groove angle here is going to be 60. Groove angle here is going to be 90. So half of 60 is 30, which means this bevel is going to be at a 30 degree. This bevel is going to be at a 30 degree. Half of 90 is 45, which means this bevel down here, 45, and this bevel over here, 45. So remember, whatever your groove angle is, if both plates are receiving that groove preparation, you're going to cut that groove angle in half, so that way it becomes your bevel angle. So if we start with arrow side, which is going to be up top here, 60 degrees cut in half is 30. So each plate is going to have a bevel of 30 degrees. And then down below, half of 90 is 45. That means each plate down here is going to be beveled at a 45. So you can see a 90-degree groove angle is opened much more than a 60-degree. Now, the next thing we're going to talk about is the root opening. So this is talking about the spacing between the plates. So are you going to have a big spacing between the plates? Or are you going to have a little spacing between the plates? This is going to be given as the root opening. So how does that look on a reference line? So when looking for the root opening information on a reference line, let's say this is our reference line right here. And let's go ahead and say for this example, we have a V groove. Now, the information for a root opening is going to appear right here. So either at the very bottom of the weld symbol, if it's on arrow side, and if it's on other side, it's going to appear right above. So I know you're probably thinking, well, that's where the groove angle went. And while that's still correct, the root opening actually appears first. So if we were to include a root opening with a groove angle, the groove angle would go simply just a little past. So we start with the root opening, then we have our groove angle. Okay? So root opening first, groove angle second. And you'll be able to tell these apart easily because your angle is always going to have this little symbol just above and to the right. So this is your symbol for degrees, and that's how you can tell your groove angle apart from your root opening. So in this example, we have a V groove and we have our 2 plates, and the root opening is calling for 1/2 inch. So that means from the edge of your plate here to the edge of this plate over here, this should equal 1/2 of an inch. It's fairly straightforward. Now, let's say that a different number appears here. Let's say instead of 1/2 of an inch, we're given 1/8. This means that our plates are going to be much closer together. So instead of 1/2 inch being right about here, these plates are going to be closer to each other, more like about right there. So root opening is fairly straightforward. Whatever your measurement is for the root opening, that is going to be your spacing between the 2 plates. Whether they're beveled, one is beveled, one is not, or both of them are beveled, this is going to be the root opening between those 2 plates. So let's say, for example, we actually do bevel both of our plates. So let's say we have a V groove with a 90-degree groove angle, and this is on arrow side. So our plates would be beveled about like this. Now, there is no middle to go across, so we're measuring from these 2 corners. So that right there should equal 1/8 of an inch. Now let's say both sides have a V groove. So let's say both sides have a V groove, and let's say this one also has a 90-degree groove or groove angle. Now when you have 2 different groove weld symbols on the reference line, you only need the root opening to appear on one, because the root opening here is also going to determine your root opening up here. So there's no reason to have your root opening appear twice on the same reference line. Write it down once, and that's going to be your root opening for the joint overall. So let's say your plates are beveled like so. Your root opening is going to be the distance from right here to right there. So again, that distance should equal 1/8 of an inch, because that's your root opening that's being specified on the welding symbol. Now let's say we have something else. Let's say that instead of V grooves, we're working with a double bevel. So arrow side, 1/8 root opening, 45-degree groove angle. Other side, 30-degree groove angle. Well, remember, only one of these plates is going to receive both of those bevels. So you can kind of think of this as just being the angle that's being given to each single bevel. But the overall concept is that this is your groove angle. Starting with arrow side, 45-degree. We're going to start about the midpoint because there is no depth of bevel given, and our bevel is going to look something like this. Oops, sorry, that's a little steep. Like that. And the bevel down below is going to be 30 degrees, so it's going to look more like this. Now, how this is going to work is from this edge to this point right here, that's going to equal 1/8 of an inch. So different examples of different groove preparations, just to show you that root opening is as straightforward as it can be. Whatever appears as your root opening, that's going to be your spacing between the two plates. So that's pretty much it. We discussed a lot about groove welds. We talked about single bevel. We also talked about double bevel, and how single bevel means only one plate is receiving a bevel on one side, either the top or the bottom. And in a double bevel, still only one plate is being beveled, but it's going to be on both sides. So actually here, let me go ahead and draw the example. So single bevel, only one plate is being beveled. Double bevel, still only one plate is being beveled, but now it's being beveled on both sides. We talked about a single V, where one side of both plates is being beveled. And we also talked about a double V groove, where both plates are receiving a V groove, so that way the joint itself looks something like that. So single bevel, double bevel, single V, double V. Take a look at the shape that is created by the grooves, and you'll start to notice that they are going to look the exact same as the symbol for each of these types of groove. So for a single bevel, you would see it appear on the reference line either like this or like this. Double bevel, either way, you're going to see it appear on both sides of the reference line. Single V groove, you'll see it appear either like so or like that. Double V groove, you're going to see the V groove symbol on both sides of the reference line. So we talked about depth of bevel. So if we've got our two plates, we can determine how far down this bevel extends past the surface that's being pointed out by the reference line. So either our bevel will begin somewhere like right here, or if the bevel extends all the way through the entire thickness of the metal. So are we beveling only part of the plate, or are we beveling all the way through? This is going to appear on the reference line to the immediate left of the weld symbol. Now, if there's nothing there, go ahead and assume that you're beveling through the entire thickness of the plate. We also talked about groove angle. So if we have one joint up here, we can see if they're going to have a very wide open groove angle, or if they're going to have a much smaller open groove angle. So this will be given to us on the reference line, appearing like something like that. So you're always going to look for this small little circle in the upper right hand corner of the number, which is the degree symbol. So whenever determining the groove angle, look for that symbol right there. That's going to be your groove angle. Now remember, the groove angle is taking into account the entire angle of both plates. So let's say, for example, these two plates right here, the groove angle is going to start on this side of the bevel and end on that side of the bevel. So this angle right here should add up to 90 degrees. Now, if only one of these plates is receiving a bevel, the same concept applies. Starting from one plate to the other, this should equal 90 degrees. Now I know that doesn't exactly equal 90 degrees, in this illustration, but still same concept. So whatever the groove angle happens to be, it's going to be located right here with that symbol. And we also talked about root opening. So this is going to appear just below the weld symbol if it's on arrow side, and this pretty much bumps down the groove angle one spot lower. So if you're ever seeing both bits of information like this is going to be your root opening, and this is going to be your groove angle. So remember, the differences between the two is this symbol right there. So whatever your groove opening happens to be, let's say 1/8, your plates are going to be spaced apart 1/8 of an inch from each other. Just the same if instead of 1/8, let's say this were 1/4, your spacing is actually going to increase. Pretty straightforward. One thing we did not talk about is weld size. So in the grand scheme of things, if we have, say, a V-groove weld symbol, put our root opening, put our groove angle, and we also put our depth of bevel, weld size would be located within parentheses to the left of the weld symbol. So kind of bumping out your depth of bevel one spot to the left. So real quick, this is root opening. This is groove angle. This right here is depth of bevel. And in these parentheses is weld size. Now this is all when it comes to groove angles. So the reason why I didn't talk about weld size in this symbol, or the reason why I didn't talk about weld size in this video, is because all the examples that I gave to you would be considered complete joint penetration. There are times where you'll see weld size being called out and the weld will still be considered complete joint penetration. But what I found is that most cases, when the weld size is being determined, it also means that the joint could be partial joint penetration, and that'll be something that we talk about in the next video. So this is just to kind of keep things short, and I will continue on with weld size examples in the next video. So stay tuned.